All right, this is the second page of the Pythagorean theorem assignment, and it says we can prove the Pythagorean theorem works by using a geometric model and some basic algebra. Let's start with a right triangle whose sides measure 3 inches, 4 inches, and 5 inches. So we're gonna fill this one out, 3, 4, and 5. The side lengths of each square are the same as the side length of the triangle side to which it is connected. Label each side length. So the small square has a side length of 3 inches. The medium square has side lengths of 4 inches, and the large square has side lengths of 5 inches. The side length of a square S squared, the side squared, gives you the area of that square. The area of the small square is 9 inches squared. The area of the medium square is 16 inches squared. And the area of the large square is 25 inches squared. The area of the small square, a squared, plus the area of the medium square, b squared, equals, so 9 plus 16 equals 25 inches squared. Those two squares together have the same area as the large square. Okay, then next on here, we're gonna work on finding these missing angles. So on here, if we have a squared plus 12 squared equals c squared. 8 squared is 64 plus 12 squared is 144 equals c squared. So together those two equal 208 equals c squared. So then I need to do the opposite of squaring it, which is taking the square root of 208, which ends up being 14.4. So on this, c equals 14.4. On the next one, we're gonna take 5 squared plus, we don't know what b is. So b squared equals 15 squared. So 5 squared equals 25 plus b squared equals 15 squared is 225. So on here, I need to move the 25 over there. So I'm gonna subtract it. So now I have b squared equals 200. Which, remember, the opposite of squaring it is taking the square root. So the square root of 200 is 14. So b will equal 14.1. That is the square root of 200. So that is what that one will be. And the next one, this is my right angle right here. So I have a squared, I don't know what a is, plus 9 squared equals 11 squared. So a squared plus 9 squared is 81, and 11 squared is 121. Now I need to move that 81, so I'm going to subtract it and subtract it. So now I have a squared equals 40. So remember, the opposite of squaring it is taking the square root. So the square root of 40 equals 6.3. So on this one, angle A equals, or leg A equals 6.3. Okay, so then down below we find out, could each set of numbers be the 3 sides of a right triangle? So remember, like the triple effect. So on this one, we're gonna go 10 squared plus 20 squared to equal 30 squared. So on those, if we do those out, so if we do on here, 10 times 10 is 100. So I have 100 plus 20 squared is 400, and 30 squared, 30 times 30 is 900. So 100 plus 400 does not equal 900. So that one is no. The next one, we have 9 squared plus 12 squared equals 15 squared. And on it, I know that 9 squared is 81 plus 12 squared is 144 equals 15 squared is 225. So let's see if 81 plus 144 is 225. So this one is a yes. That one works. Okay, next one we have 10 squared plus 24 squared equals 26 squared. So again, 10 squared is 100 plus 24 squared is 576 and 26 squared is 676. So that actually works because 100 plus 576 does equal that. So that's a yes. And then this last one, let's do it down here. 4 squared plus 15 squared equals 17 squared. So let's see, 4 times 4, 16, right? 16 plus 15 squared is 225 equals, let's see what 17 squared is. 289. And that's not going to equal out. So that one is a no on that one. So it would be over here, no, yes, yes, and a no. Okay, and finally, the last one on this side of the page, find the missing measurement. So I have A is 25 yards, so I have 27. 27 squared plus B squared, I don't know, equals 45 squared. So 27 squared equals 729. Plus B squared equals 45 squared is 2025. So now I need to subtract 729 and subtract 729 is B squared equals 1296. So now, sorry, this is getting all over the place. I'm going to take the square root, because the opposite of squaring it is the square root of 1296. So let's see, and that is 36. So my B on this one is 36. And that is the second page of the Pythagorean theorem assignment.